everyone. I'm Ilgaz. I'm a machine learning engineer at a Montreal, Canada-based startup called Plumfind. As you can see in our logo, in in somewhere here in the corner. And Plumfind uses AI and cloud technologies to help brands stay ahead of the curve and make smarter business choices. For details about Plumfind, please check the links in the description in the below. And besides, well, here's the topic, Amazon S3. I'm pretty excited for that. It's a new preview service for building modern AI applications. This presentation will guide you through building applications with S3 Vector from basic concepts to practical implications. So let's go with table of contents. We will cover 12 key areas today, starting with an introduction to S3 Vector, exploring its features and architecture, then dividing into hands-on implementation with step-by-step tutorials using Python SDK, and finally looking at integrations and best practices. Now let's continue with introduction to AWS S3 Vector. S3 Vector is actually like Amazon's purpose-built vector database service, and currently it's in preview mode. It's designed specifically for storing, indexing, and querying high-dimensional vector data, perfect for AI applications like semantic search and recommendation engines and RAG, Retrieval Augmented Generation workflows. As a managed service, it eliminates the complexity of managing vector infrastructure, and that's actually one of the key points here. And we set key points. Let's talk about the key features then. First, it's purpose-built for vector storage within S3, providing dedicated APIs for vector operations. It's scalable and also cost-effective as a managed service. Security is built in with encryption and IAM controls. Most importantly, it integrates seamlessly with AWS ML services like Amazon Bedrock or OpenSearch for accelerating your Gen AI application development. And the architecture is pretty straightforward. Vector buckets are special S3 buckets designed for vector data. And within these buckets, you create vector indexes to organize and index your embeddings. The service integrates seamlessly with Bedrock embedding models, and you interact with it through standard AWS APIs and SDKs with full IAM and encryption support. Yeah, here is your roadmap to get started. First, create a vector bucket in the S3 console, then identify a vector index with your specific dimension and distance metric requirements like cosine or Euclidean, and generate vector embeddings using services like Bedrock. As we said, it's seamlessly integrated. Insert these vectors with metadata into your index. Finally, query for semantic similarity. Well, let's walk through each step then. Yes, step one. Creating a vector bucket is, as you can see, it's pretty simple. Navigate to the S3 console and select vector buckets there. Click Create Vector Bucket and provide a name like media embeddings. You can see that there are some limitations for and rules for the naming. And choose your encryption method, either SSE S3 or SSE KMS. And yeah, remember, both the bucket name and encryption settings are immutable after creation, so you can't change after you create the bucket. So yeah, pay attention. And step 2, inside your vector bucket, create a vector index by clicking create vector index, and specify your index name, dimensions, and distance metric. Like, if we can talk about briefly about cosine or Euclidean. A cosine for angular similarity and Euclidean for straight lines distance. And also you can check the model that you want to use so that you can find the proper one. Also, you can add a non-filterable metadata keys for reference data. And these settings cannot be changed later, as we talked in the previous slide for encryption. And yeah, you see, encryption and bucket name. You can change those after creation. So here, now let's see the code in action. This Python example shows how to use the AWS SDK with Amazon Bedrock to generate embeddings and insert them into your vector index. Here we are using Titan text embeddings v2, and the 1024 dimension is a default here. So we will use it. And this 1024 dimensional vectors from movie descriptions, and then we're gonna store them with metadata like genre and source text using the put vectors API. For querying, we use the same embedding model to convert our search query into a vector, then use the query vectors API to find similar vectors. Notice that we have two examples here actually. Basic similarity search, returning the top 3 matches, and filtered search, where we can narrow results by metadata like genre. The API returns distances and metadata for each match. For easier automation, AWS provides the S3 Vectors embed CLI, yes, with simple commands for embedding and querying. And more importantly, S3 Vector integrates with, again, Amazon Bedrock knowledge bases for manage RAG workflows, and with OpenSearch for advanced search capabilities, either exporting data to OpenSearch or using S3 as a cost-effective vector backend. And yeah, to wrap up, follow AWS best practices for batch operations, and careful metadata design and proper security configuration. Those are very important. And yeah, this service is ideal for semantic research, AI retrieval systems like RAG, and content recommendations, and cost-effective vector storage. I encourage you to explore the AWS documentation and try the hands-on CLI and experiment with Bedrock and OpenSearch integrations. And yeah, we are gonna put the links into descriptions, by the way, so no worries about it. And I really wonder your feedbacks and requests. Please feel free to make a comment, or yeah, you can text me on LinkedIn. Yeah, please check the documentation as well. That's very crucial. So have a nice day. Bye.